Hello everyone. Today we're going to solve this question. This question is from Canadian mathematical contest that run by University of Waterloo here in Canada. One of the few mathematical contests that run here in Canada. This is from Euclid contest, right? So I think I mentioned in one of my videos. So University of Waterloo run contests from grade 7 to grade 12, and each contest has its name, and many of them, those names are after famous mathematicians. So Euclid is a Greek mathematician, so who are interested in history can read his biography and so on, but we are interested in solution for this question. Okay, let's try. The equations x² plus 5x plus 6 equal to 0 and x² plus 5x minus 6 equals to 0 each have integer solutions, whereas only one of the equations in the pair x² plus 4x plus 5 equals to 0 and x² plus 4x minus 5 equals to 0 has integer solutions. So first pair has integer solutions, both of them, and in the second pair only one has integer solutions. So question A, show that if x² plus px plus q equals to 0 and x² plus px minus q equals to 0 both have integer solution, then it's possible to find integers a and b such that p square equals to a² plus b square. Okay, so a, b, and p are Pythagorean triple. And then part B, we'll get there, determine q in terms of a and b. Okay, let's think. Part A. So what do we know about the solutions of the quadratic equation? So how to find it? We're not going to do factoring here, so we can one of the methods to find solution for quadratic equation is to use quadratic formula. Minus p plus minus square root of p square minus 4 times 1, right? Coefficient of x squared is 1 times q over 2 times 1. Okay, or p plus minus square root of p square minus 4q over 2. Okay, this is for the first equation, and for the second it will be similar. The only difference will be is because we have minus q in the second equation, so the difference will be minus p plus minus square root of p square plus 4q, right? Because q is negative in the second equation, over 2. So for these two solutions, right, for first equation and second equation, to have integers as solution, one condition must hold, and this condition that expression under square root in both, right, and p square plus 4q, they both must be perfect squares, right? In other words, first expression, let's make it equal to n square, and second will be p plus 4q equals to m square. Okay, so this is condition for solutions to be integers, right, for this pair of equations. Okay, next step, right? So what we're going to add what we're gonna do, I already said it, we're gonna add these two equations, right? And what we get 2p squared equals to n squared plus m squared. Looks good. And then we're gonna divide p squared by 2, both sides by 2, and we get okay. Then we have 1 over 2 n squared. Okay, but we want to make it to look like m squared. This is how it's supposed to look, the final answer, in this form. Okay, and we're here almost there, except we have these coefficients 1 over 2 with n squared, and same with m squared. But we have these coefficients 1 over 2 which are not perfect squares, so we must do some tricks here to make both terms to be perfect squares. Okay, so we're gonna work on it on the next page. We have p squared equals to 1 over 2 n squared plus 1 over 2 m squared. Okay, so what I'm gonna do, I'm gonna multiply this expression by 2 over 2. Okay, then we're gonna open brackets, so we get 2n squared over 4 plus 2m squared over 4. Okay, so then we can write them as n squared over 4. Oh, this looks like perfect square, right? Plus n squared over 4 plus m squared over 4 plus m squared over 4. So it looks like quadratic expression, except we're missing two terms here, right? Two terms. Okay, let's think what terms we're missing. Right, we know that in quadratic equation, so if you expand this formula, so we get a squared plus 2ab plus b squared. So here we must have this term. We need to add this term, right? So it will be 2 times n over 2 times m over 2, right? So we added this term, and we need to subtract this term. And where we're going to subtract? We're going to subtract, right, because we have these two additional terms. So we're going to subtract 2nm over 2 times 2 plus m squared over 4. Okay? So I'm going to take it in a frame so it stays there. Okay, so next step, right? So we can now put brackets and see that first bracket is a quadratic formula, and we can rewrite it as n plus m over 2 squared, right? And second bracket will get n minus m over 2 squared. So our answer is m squared equals to n plus m over 2 squared plus n m over 2 squared, whereas a equals to n plus m over 2 and b equals to n minus m over 2. Here we go. We have our Pythagorean theorem in the form p squared equals to a squared plus b squared. So we answered part A. Okay, let's do part B. So we need to express q in terms of a and b, right? So I just left reminders here. So how we expressed discriminants of both equations. So in the first equation, discriminant is p squared minus 4q equals to n squared, and for the second equation, discriminant equals to p squared plus 4q equals to m squared. Okay, so let's pick up first discriminant, right? So p squared minus 4q equals to n squared. So from here we need to express 4q. So 4q equals to p squared minus n squared. Okay, so p squared we know from part A, p squared equals to a squared plus b squared. Okay, so what is n squared? Okay, so how to find n? We can find n from here, from this part and this part, right? So we can build two linear equations, and by elimination we can find n. Okay, let's try to do it. So from first equation, so we have n equals to what? N equals 2a minus m, and second, n equals to 2b plus m, right? So we're gonna add these two equations. So 2n equals to 2a plus 2b, or n equals to a plus b. Okay, good. So now knowing that, we can continue. So 4q equals to p squared is a squared plus b squared minus n squared. So n equals to n plus b squared. We're going to open brackets, expand first, minus a squared plus 2ab plus b squared. If we open brackets, we're going to get a squared plus b squared minus a squared minus 2ab minus b squared. And the final answer is, so these terms cancel each other. We have negative 2ab. So 4q equals to negative 2ab, or q equals to negative ab over 2. Okay, so that's the answer. We can use second discriminant and see if we get to the same answer. Okay, we're gonna try it. Okay, now we're gonna try second discriminant. Now we're gonna try second discriminant, p squared plus 4q equals to m squared. From here, 4q equals to n squared minus p squared. And again, we know p squared from part A equals to a squared plus b squared. So what is m squared? So again, we're going to use a and b that we've found in part A, and we're going to express m, right? So m equals to 2a minus n, and from the second m equals to n minus 2b, right? So if we're gonna add these two equations, so we get 2m equals to 2a minus 2b, or m equals to a minus b. Okay, so now we're going to substitute. For q equals to a minus b squared minus a squared plus b squared equals, we're expanding, a squared minus 2ab plus b squared minus a squared minus b squared equals, so a squared, b squared cancel each other, and we get negative 2ab. For q equals to negative 2ab, and q equals to negative ab over 2. So we arrived to the same answer, so we did everything correct. That was tough questions. It took me a while. Part A is requires some thinking, right? So how to make from what we have, make it into Pythagoras theorem. Anyway, that's why we learn math. That's why we stretch our brain, train our brain to be able to solve complex problems. Anyway, subscribe to my YouTube channel. I post daily. I'm trying to post daily questions from mathematical contest that run here in Canada, and sometimes I film short movies, not movies, videos about life in Canada. And like my page on Facebook, you'll enjoy it. Thank you for watching and being with me.